Hello again and welcome back. So we're going to take a look at some more integrating by substitution. This time we're going to take a look at some definite and indefinite integrals. Okay, so we're going to evaluate this definite integral, and the way that we know that it's definite integral is because it actually has bounds. Okay, we have a lower bound and an upper bound, which means we should get an answer that is a number. Okay, so we're going to start this process by first observing what we have. This is not a simple, straightforward function, which means I'm probably going to have to use substitution. So let's go ahead and start that process. I'm going to take a look at this first part in here. The derivative of x squared plus 1 would be 2x, and I happen to have an x sitting right here. So that's what I'm going to be using. So we're going to go ahead and start this process. We're going to do u equals x squared plus 1. Our derivative of that would be 2x dx. And of course we want to solve for dx, so we're going to divide both sides by 2x. That's going to give us 1 over 2x du equals dx. Alright, so let's go ahead and see if we can get this going. We're going to do our definite integral from -1 to +1. And the first term we did nothing with, so it's going to remain there. Our next term became a u to the third power, and dx became 1 over 2x du. So let's see what cancels. We've got the pair of x's here that will cancel, and then I can take the 1/2 that's left and put it on the outside. So let's go ahead and rewrite. We've got 1/2 the integral from -1 to +1 of u cubed du. So we're going to integrate. We're going to add 1 and divide by that sum. That's going to be 1/2 times the integral from -1 to +1 of 1/4. Oops, I don't know why I wrote the integral sign there. I am so sorry. We didn't need the integral. We already integrated. So times 1/4. That's the dividing by 4. That's right here. Times u to the 4th power. Now, in this case, we do not do the plus c here, and that's because this is a definite integral. And what we do instead is we write a vertical bar, and we put the lower bound down here and the upper bound up here. So let's go ahead and simplify. 1/2 times 1/4 is 1/8. We're going to resubstitute u. That means x squared plus 1. Oops, there we go. To the 4th power, and then from -1 to +1. So now what we're going to do is we're going to follow the fundamental theorem of calculus, where we input the first upper bound into our function for x, and then we subtract the value that we get when we plug in our lower bound. That is all the fundamental theorem of calculus is. It sounds way more complicated than it actually implies. So we're going to start this with a set of brackets, just so that everything is really well organized. We have 1/8, and the x is going to become a 1, so 1 squared plus 1 to the 4th power. So that completes the upper bound. I'm going to close that bracket, subtract, open another bracket, and now we plug in the lower bound. So 1/8 times -1. I'm going to keep that -1 in its own parentheses because it's negative, and when you raise it to different powers, it can change the sign, so be careful. Plus 1 to the 4th power, and then close that bracket. And now all we need to do is enter this into our calculator or work it out in our heads or by hand, and we should have our answer. So I'm going to do this by hand in my head, so you can see how the process works, just in case you want to know. So the first part that we have here, I'm going to keep the 1/8. Now 1 squared is 1, 1 plus 1 is 2, 2 to the 4th power, let's say 2 times 2 is 4, and then times 2 is 8, times 2 is 16. So that's going to be multiplied by 16. Next part, we're going to do the same process. So 1/8 times, and now we're going to do -1 squared, and when we do that, we just get +1. So we're actually going to get the same exact thing for this part right here. We're going to get 2 to the 4th power, which is again 16. Now if you take a look at this carefully, I have the same exact amount subtracting by the same exact amount. Well, the same thing minus itself is a very simple answer. It is nothing. It is 0. So all that work for a little 0. It happens. Let's take a look at one more. All right, here we go. So this time we also have a definite integral from 1 to 2 of 2x squared times the square root of x cubed plus 1 dx. Now again, since we've got a square root, I'm going to rewrite it. This is from 1 to 2, 2x squared, and then this part becomes x cubed plus 1 to the 1/2 power dx. All right, so again we got to choose what our u will be. And it looks like this is going to be our u because the derivative of x cubed is 3x squared. So because that x squared is sitting right here, I won't have to solve for it like what we did in the last couple examples where we actually have to solve for x all over again. So that's awesome. We're going to have our u right here and we can get started. So u is going to be x cubed plus 1. du will be 3x squared dx. Divide both sides. 1 over 3x squared du is now the dx. So let's go ahead and start substituting and we'll see what happens. So we've got the integral from 1 to 2. 2x squared, haven't done anything with it yet, so I'm going to leave it as is. This became the u, it's to the 1/2 power. And our dx is now 1 over 3x squared du. So let's go ahead and cancel some stuff out. The x squareds are going to cancel, so they're gone. Okay. Now I actually have a 1/3 times a 2, which is 2/3, and all of that together can be taken out. So these two coefficients you can take out at the same time. So the 2 and the 1/3 make 2/3, and I'm going to put that on the outside of the integral. So 2/3 right there. And now we're going to do this from 1 to 2. And all I have left in here is u to the 1/2 power du. Not too bad. So we're going to add 1 to this, divide by the sum, which is 3/2, and we're going to go ahead and start this. So we've got 2/3. Now I'm writing multiplication, and then remember that when we divide by 3/2, it's the same thing as multiplying by 2/3. So there we go there, and then u, and then 1/2 plus 1 is 3/2. And then we're going to use the vertical bar from 1 to 2. And we're going to go ahead and resubstitute our u and simplify these fractions. 2/3 times itself is 4/9. Our u originally was x cubed plus 1. And that's going to be to the 3/2 power. And that is from 1 to 2. So I'm going to get the fundamental theorem of calculus started here. I'm going to go ahead and start some brackets. By the way, I'm going to show you another way of setting this up, just in case you have a different preference. If you have a big coefficient sitting out front, you can start this process like this. You can do the 4/9 and then open up a huge set of brackets with the upper bounds in one, subtracting the lower bound in the other. Now, if this is more confusing, if it's not helpful, then don't do it. Leave the 4/9 in each of those different parts. So let's go ahead and start. I'm going to plug in the upper bound first for x. So that's going to be 2 cubed plus 1 to the 3/2 power. And then over here, I'm going to plug in 1 for x. So that's going to be 1 cubed plus 1 to the 3/2 power. Now, I am not good with rational exponents like this, so please feel free to use your calculator along with me if you'd like to. And I'm going to just go ahead and input this entire thing and get our answer. And it looks like we get a pretty icky answer. It's 10.743-ish. Okay, so there we go. Please double check this using your own calculator. Now, I do want to bring this next part up. And it's a shortcut to check your work using your graphing calculator. So I can't show you this unfortunately by a picture, but I'm going to show you the process on how you can do this. So if you want to double check, and this is exactly how I put this in my own calculator to get my answer. On your calculator, right under alpha, you have a key that says math. Access that and choose the 9th option. It will say function integral or fn_int. Okay? When you do that, this syntax should pop up on your screen. Okay? Now, with the problem that we just had, and by the way, it's going to start you off on this lower box. It always does. You want to put your lower bounds in that box, and you can use the arrows on your keypad to just shift around wherever that you need to go. So our first problem was, let me just remember, so from 1 to 2. So this would be the 1, okay? Up here would be the 2. Come on. There we go. And then in here you input your function, okay? And you want to be really careful as to how you input it. So all of that mess that we had goes right there. This box right here, always use the X key, okay? Not the letter X. I'm talking about the X, T, theta, N button right to the right of alpha. If you enter all of that incorrectly, it should pop out the same exact answer. Okay, so that's a really great way for you to check your work. Thanks again for watching. Have a great day.